Polynomial rollercoaster virtual reality game. This is a stimulation game in which players create a roller coaster theme park by constructing polynomial functions. Learner centered instruction is built on the foundation that each learner is not a blank slate. Instead, they enter the classroom with a conceptual understanding or misunderstanding of the subject. Creating opportunities for students to draw upon their previous knowledge, this environment makes the students actively participate in the classroom material, where as a result, the instructor can build upon what the students already know and can do. A learner centered classroom seeks to avoid using the old model of I do, you do, we do by eliminating direct teacher instruction to a more hands on discovery approach. Within virtual reality, one can create any learning environment to see which environment may be the best fit. VR software has been used to connect learners from a unique, impactful learning experiences. For the project on polynomial roller coasters, each person is equipped with a personal headset instead of controllers. With this technology, the learner can interact with the others in the virtual space. Unlike traditional teaching environments, VR uses this immersion to create a safe space for learners to experiment, connect, and practice opportunities that might not be as welcoming as an in person classroom session. The main benefit of this flexible learning environment is that the activities can be incorporated and the experiences one may gain from the virtual reality. The benefit is that learners can explore and learn using prior knowledge, skills, interests, and beliefs. A learner can go through an entire learning cycle in minutes as compared to days with the aid of the VR system. This makes learning more impactful and crucial to a student's success in future projects and courses. The target audience for this polynomial function roller coaster game is designed for high school Algebra 2 students. The age is approximately between 14 and 16. However, this game may be used for any level of math above an Algebra 2 setting that may incorporate any polynomial function as well as limits. Then we go to our concept. So the concept for this game is built on a virtual reality. Virtual reality offers a user the 360-degree sixth sense transformation that allows for total immersion and connectiveness that helps users use pre-existing schema to generate and retain memories. The purpose of the polynomial roller coaster VR system is to immerse learners into a total mind and body experience that requires students to use their mathematical reasoning to build and operate a roller coaster. Unlike most virtual reality video games on the market today, they are designed from a first person point of view. This game is designed to be a first person point of view as well as a bird eye view when building and constructing the roller coaster tracks. The games that only allow first person view exploit their users' sense of scale and dimension, often overwhelming first time users. Therefore, there is a need for something on the halfway market that helps customers smoothly transition to VR education, and this is the polynomial roller coaster. Previous research on VR has focused on the evaluation and review of design rather than the implementation across domains. This project aims to fill in the gaps offered by the VR game system to help the transition to educational applications become smoother. Through virtual reality, users have the ability to experience real life gameplay with the comfort and flexibility not offered in the first person models. This game allows users to implement skills learned through the content curriculum on polynomial functions to develop and create a world-class roller coaster. Using the functions created by students, the VR game will use the combined functions to create the roller coaster tracks. For the learning theories used, we focus on the constructivism and Meyer's cognitive theory of multimedia learning. In the design of the VR program to create roller coasters by using specific characteristics of functions, the use of the constructivist theory and Meyer's cognitive theory of multimedia learning is used to present the students with a realistic background of a theme park. Using the environment to present it to the students will be able to visualize the space needed to be built. The constructivist theory plays a part in this development by having students pull from their prior knowledge of theme parks and physical space. Using the concept of physical space to build the roller coaster, so students would be able to determine the maximum height and radius permitted to build a successful ride. In addition, when constructing the tracks, the students will be utilizing the knowledge of polynomial functions to transform the function with restrictions to create a workable and safe roller coaster